Alright, so we started looking at 13.2 the other day, right? And I want to go back over this real quick. I built something that hopefully helps. Okay. So, what we started talking about is this first section right here, right? This sector is 30 degrees, which in radians is pi over 6. Is everybody okay with that? So they're the same thing. Saying something is pi over 6 is the same thing as saying that something is 30 degrees. Okay? So it's just another way of counting. Like you can say the evens, or you can say 2, 4, 6, 8, dot, dot, dot. Right? Everybody okay with that? Yes, no, maybe? All right. So what's important here, though, is why is it pi over 6? Well, where's pi? How much of the circle does pi represent? No, that's pi over 6. It's over 6. So where's pi? Who remembers? How many degrees is pi? 180. So pi is over here, right? So a half a circle is considered 1 pi. So why is this pi over 6? Well, if we divide the circle up, all right, so if I keep forming pi over 6 sectors here, how many 30-degree marks fit in a quarter of a circle? 3, which makes sense, right? Because it's 90 degrees, so 30, 30, 30. Right? So how many pi over 6s from 0 here to 90 degrees? 3 pi over 6s, right? So that's 3 pi over 6, which reduces to what? Pi over 2, which isn't that what you have labeled on your chart? Yes, no, maybe? So if I kept going with this, right, there's 4, there's 5, and there's 6. Okay? So why is it pi over 6? Well, because 30 degrees divides 1 pi up into 6 pieces. Is everybody okay with that, right? 6 times 30 is 1 pi. Are there any questions on that? So that's where it's really coming from. So if you remember that this is pi over here, then everything else just kind of flows. All right, so I'm going to do the same thing, but with pi over 2, because it won't take nearly as long. So here's 1 pi over 2, right? So it cuts pi into 2 pieces. So I have 2 equal pi's over here, like that. Everybody okay? Yes, no, maybe? So I could keep going with that, right? I have another one down here. So how many pi over 2's do I have now? 3, and what did you have written down here at 270? 3 pi over 2. So when it comes to remembering the radians, all we're doing is we're dividing the circle up into sectors, and then we're counting how many of that size sector can we fit in 1 pi or in 2 pi's. Is everybody okay with that? Yeah? Does that make more sense? Based off of what we did Friday? Or no, because it seemed like you guys were having a really hard time counting everything out. Did that help, or does that hurt? Okay, so for degrees, right? What's this? And then so you should be able to just work your way through. 240, 270, 300, 315, 330, 360. Everybody okay with the degrees, right? Everybody have this filled in on the unit circle? All right, so how many radians is 0 degrees? 0. Okay, 30 degrees, right? How big of a sector is that in radians? That's a pi over 6, right? Pi over 6. Because what's 180 divided by 30? 6. So there's 6 30-degree sectors between 0 and 180. Everybody okay with that? Yes. Basically, for the first quadrant, yeah. If you don't remember the radian mark, instead of just memorizing it, you can find it if you know the degrees. But you need to know one of them, okay? You either need to know radians or you need to know degrees. All right, and then you need to know how to go from one to the other. It depends on which test. Okay, if it's the memorization quiz that goes along with this, no. Okay, so 45, right? What's the denominator on a 45-degree mark? So what's 180 divided by 45? 4. So that's the denominator here, right? And 180 divided by 4 is 45. So that's 1 pi over 4. Everybody okay with that? Yes, no, maybe? All right, what's 180 divided by 60? 3, so you get pi over 3, right? 180 divided by 90. pi over 2. So if you notice, in the first quadrant, all of the numerators are 1, right? And you can find the denominators if you know the angle measure. And then once we have the first, we know what to count by. Okay? So like 120 degrees, right? Is that going to be a 60, a 45, or a 30? A 30 or a 60, right? So let's go with 30. How many 30s are there in 120? 4, right? 1, 2, 3, 4. Everybody okay with that? So what is this going to be in radians? 4 pi, and how many, what was the 30 degree? Over 6, but can that reduce? 2 pi over 3. Which again, 1 pi over 3 is 60, right? So how many 60s in a 120? 2, so pi over 3 becomes 2 pi over 3. That's all I'm doing is counting by the sector once I know how big the sector is from the first quadrant. It's the same thing. Because it depends on if you're counting by 30s or 60s. Make sense? Right, so 135 is connected to a pi over 4, right? Everybody see that? They're across from each other? So how many 45s are there in 135? So what's 135 divided by 45? 3, right? Which makes sense because we've got 1 sector here, 2 here, and then 3. So I get 3 pi, and what's the denominator for a 45? 4. So can 3 over 4 reduce? No, so that's just 3 pi over 4. Everybody okay? So it's a distance, right? It'd be like if I gave you the distance from here in miles and kilometers. Okay? Is it going to be the same actual distance? Yeah, it's just a different way of representing it, right? Same way with this. 30 degrees is pi over 6. They mean the same thing. Everybody okay? Yes, no, maybe? So they both represent the exact same sector. It's just 2 different ways of naming it. But because sometimes we use one and sometimes we use the other, it's important that you can navigate between the 2. Well, a pi is from 0 to 180. Okay? So like how many 30-degree sectors are there in 180 degrees? So what's 180 divided by 30? 6. So that means that there's 60 30-degree measurements between 0 and 180, right? So if I change 180 to be pi, then that would become pi over 6. Right? 180 divided by 6 is 30. Pi over 6 is the same distance. Pi is always on top. Because this is past the first quadrant, right? So 120 degrees, we're going to use something from here that goes into 120. So like, what's 120 divided by 30? 4, right? So that means that there's 4 pi over 6s, right? So I've got 1 here, 2, 3, 4. So this distance is equal to 4 pi over 6, which is 2 pi over 3. Or I can use 60, right? What's 120 divided by 60? 2. So 160 degree, 260 degree equals 2 pi over 3s. So again, we're just breaking it up into sectors. Can you see it, or do you want me to draw it out? It's coming from here. Oops, wrong button. So this is 1 pi over 3, right? They're a different size of sector. But if I put in a second pi over 3, where am I? The same spot. Okay, so it's 2 60s or 2 pi over 3s. So I get pi over 3 plus pi over 3, and what's a pi plus a pi? Can that reduce? So that's it. Right, so if I'm counting by 45s, woo, woo, woo. All right, there we go. So there's 1, right? So there's 2, right? So it depends on what you're counting by. So that's why I have the triangles, right? If you're counting by pi over 6s, then you'll use pi over 6 wedges, or 30 degrees. If you're counting by pi over 3s, then you'll use 60-degree wedges. If you're counting by pi over 4s, you'll use a 45-degree wedge. If you're counting by pi over 2s, you'll use a 90-degree wedge. But all I'm trying to figure out is how many of those wedges are there between start and stop, between initial side and terminal side. Well, for right now, because I'm just dealing with the first quadrant, I'm looking 0 to 180. Once I get into the third and fourth, I'm looking 180 to 360. But because everything is symmetrical within the unit circle, because it's a circle, everything will match up with the first quadrant. So if you know the first, you should be able to figure out everything else. So how about here? What does 150 match up with in the first quadrant? What's the denominator? 6. So I'm going to have some pi over 6. Now the question is, how many pi over 6s can I fit to here? So there's 1, 2, 3, 4, 5. So I have 5 pi over 6 regions between 0 and 150. For this one? No, because this is a 30 degree. Like 150 divided by 45 isn't a whole number. Right? So it would be like, it'd be 45 degrees plus a 15, which I don't know. Right? But 150 divided by 30 is 5. So I know that there are 5 30-degree regions from 0 to here. 5 times pi over 6 is 5 pi over 6. You always start at 0 and move up. You always start at the positive x in the first quadrant and rotate around 1, 2, 3, 4. So, and you know what's awesome about it? We do the exact same technique for quadrant 3 and quadrant 4. So, quadrant 3 is here, right? So this is my first one. I go up, and then I go across. And what is it matching to? So this is a pi over 6. But is it bigger than 1 pi or less than 1 pi? It's bigger than 1 pi, right? So again, I have 1, 2, 3, 4, 5. I'm at 6 pi over 6 to make one full circle, right? Or half a circle. Does that make sense? Because what's 6 divided by 6? 1, so that's how I get the 1 pi, right? So how many pi over 6 is between here and here? Right, so 7 total, right? Everybody okay with how I'm building these? So that way you can see that if you know the first quadrant, it just matches. Everything's symmetrical. So like the distance between 0 and here is the same as 180 in here. Okay? So like, you know how we went from 5 pi over 6 back to pi over 6? You can do the same thing. Here, up, over, it's going to be a pi over 6. Yeah, so this one matches. You go boom, 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 it's a pi over 4. So it's got to be 3 pi over 4, 5 pi over 4, 6 pi over 4. Well, no, that reduces, right? So 5 pi over 4, 7 pi over 4, something like that. So this tells us our base counting number. We're counting by pi over 4s. So that tells you how big your wedge is. Everybody okay with that? Well, this is 1, 2, 3, 4. So what's this? 5 pi over 4. Everybody okay with the connections, you think, maybe? So what's 240 match up with? It's going to be a pi over 3, right? So we've got 1, 2, 3 pi over 3. So what's this? 4 pi over 3. All right, what's 270 match up with? A pi over 2, right? So I've got 1, 2, how many? Everybody all right with how I'm building this? And then in the fourth quadrant, we do the same thing, right? Here, 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 here. It's a pi over 3. I'm going back to the base unit so you know how big of a wedge to use. We're like halfway through it, dude. I'm starting now instead of just dropping it on you like, here you go. So if you don't know what the base unit is here, right, this point, if you follow straight across horizontally, you hit another point, correct? And then if you follow straight up vertically, you hit another point. And then if you go vertical again, it gets you back to the first quadrant. Okay, which means that this value here is actually going to be a multiple of pi over 3. All right, so you okay with why I'm doing that? So it's going to be a multiple of pi over 3. So there's 1 pi over 3 here. I'm at 2 pi over 3, 3 pi over 3, 4 pi over 3. So what's this? 5 pi over 3. The only reason why I'm going back to the first quadrant is so I know how big my sector is to count by. That's it. Well, it's 60. Yeah, so 300 divided by 60 is 5. So that's how I got 5 pi over 3. Just as long as you have these memorized. Okay, and for here, there's a pattern, right? 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15. Because 30 plus 15 is 45, 45 plus 15 is 60. Well, because 45 is a really common, like the two most common triangles in the history of mankind are the 30, 60, 90, and the 45, 45, 90. So if you notice, everything up here is 30, 45, 60, and 90. Because those are what we know the most about. Okay, remember, trigonometry is like created by us to figure out the basics on known stuff so we can apply it to unknown stuff and learn more. So we're based in 30, 45, 60 because we know those triangles right off the top of our head. We know 45s are a 1, 1, square root of 2. Okay? So we can find out what the values are and then build everything else. All right, so here 315, right? Is that going to be a 30, a 45, or a 60? A 45. So we're at 1, 2, 3, 4, 5, 6, 7. So this is 7 pi over 4. 330, is that going to be a 30, a 45, or a 60? 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11 pi over 6. And then the last one here is 2 pi. Everybody okay with where that's coming from a little bit, you think, maybe? Okay, sweet.